Hi, I'm Alistair, I'm a games designer, and this is the fourth video in a tutorial series explaining how to use Asterisk PBX to create a playful telephone network, such as you might find in an escape room puzzle or something like that. So up to now, so far in the series, I've covered how to set up the Asterisk software, how to put phone handsets on the network and assign extension numbers to them so you can make and receive calls from different phones. And then in the last video we looked at some of the features that come in Asterisk. So the ability to play back pre-recorded audio or to generate messages using text-to-speech software, to make the player have to enter a code by dialing a number or pressing digits on the keypad, things like that. In this video, what I want to cover is how to trigger an incoming call that's going to make a handset ring, and the player will have to answer it and perhaps receive some instructions on what to do next via message spoken through the earpiece or something like that. So to do that, we're going to examine how Asterisk manages its outgoing calls. Now, Asterisk has a spool, a little bit like the way that your printer processes print jobs that are sent to it from your computer. So it has a queue, and in the queue, every document that is waiting to be printed, or every phone call that's waiting to be made, has a small file that has the details in it that needs to be processed, and Asterisk just works its way down the queue. So what we're going to do is we're going to manually generate a call file with all the details of the incoming phone call that we want the player to receive. We're going to place it in the queue file and we're going to let Asterisk process it. So for example, I've created a little web page here. This is running on the Raspberry Pi, and this is going to create one of those call files using PHP based on the parameters supplied in this web page. So maybe this could be something that a gamesmaster could use in a control room somewhere, and when it comes to the point that they want to deliver a message to the phone in the room, let's say they want to call extension number 1000, that's the extension assigned to this phone handset. And maybe you could have different sorts of messages that they want to deliver. This one's just going to say a string of digits. So I'm just going to hit some random digits there. And then when I make a call, it's going to create a small file with those parameters in it, copy it to the right directory in Asterisk, and Asterisk will make the call. There it is. So I'm now going to answer the call and place the receiver next to the microphone. Okay, so there you go. That used the say digits command, which I showed you in the last video, to speak the digits that were supplied on the web page. Okay, but what about if you don't want a call that has to be manually scheduled, like that one, from a website? Maybe you want a call that's triggered from an event that's happened in the room, such as another puzzle being solved, or a player movement being detected by a sensor, or pressing a button, or something like that. Well, that's fine too. So if you've got an Arduino or something like an Arduino that can access the network, that can call that web script in just the same way as the web page could. So what I've got here, this is a Wemos D1, which is very similar to an Arduino Uno. It just has Wi-Fi built in. If you're using an Arduino instead, and you've got a Wi-Fi shield or an Ethernet shield, that will be absolutely fine as well. Anything that can get onto the network can make a request to that web script that was just running on the website. So in this case, I've got a code running on the board here, which when I press the button, it's going to create a call file, just as that last example did, except this is a slightly different call file with different parameters. So when I answer this call,
hello, this is your Arduino calling.
I love the urgency in that message. Hello, this is your Arduino calling. Sounds like they're about to deliver some very important information or something like that. So yes, so this can be generated by events that happen. This can be generated manually, and the call when it's received, I mean in that case I was playing a pre-recorded audio. In the first example I was calling the say digits command, but it could also be connecting this handset to another handset, so starting a call between two extension numbers. There's lots of options. So let's crack on and I'll show you how you can do this. So here's the script that was doing the work in those last two examples, and all it simply does is it creates a call file, which is a simple text file, and places it in the correct directory for Asterisk to process. And then from that point onwards, Asterisk simply follows the same rules as set out in the dialing plan for that call, just as in the examples I showed in the last video. So this is a PHP script, and I'm using PHP because it's a language I'm familiar with, and because the Rasp PBX distribution that we're using that comes bundled with Asterisks already has a web server that's configured to use PHP on it. It's pretty easy to get up and running, so this is kind of the most straightforward way to do it. So I just sort of step through line by line what's going on here. So first of all, we define a variable called call file, and we're going to place this in a temporary file on the Raspberry Pi to start with. The reason for that is we don't want to kind of be halfway through writing the call file into the Asterisk spool directory and then for it to try to process the call while we're still writing to it and things like that. So we're going to create the entire thing in a temporary location first, and then when it's all done we're just going to copy it into the spool directory at the end. So we'll start off in the temporary directory, and we'll just call the file webcall.call to start with. You can call it anything you want, it really doesn't matter at this point. And having defined where and what we will call the file, where to save this temporary file, we'll open a file handle to that call file there, and we'll set that to be able to write to the file. So long as this is a location that the script is able to write to, this will give us a file handle that we're going to be able to use for the rest of the script to write into that file. And then the next section here, so having sort of got this ability to write to the file, the next section here is where we actually define what the contents of that file is going to be. Now, there's different options that you can put in a call file depending on how complex you want to make it, and I've included a link here to a good web page that does explain many of those details. But what I've actually put is I've actually put in 3 different examples of call files here in a switch statement. So depending on the parameter that's passed to this script, which I've just called call type, it will generate 3 different sorts of call files. So if you call this script and say call type say digits, for example, which is the first one, what it's going to do is it's going to create a call file, and the contents of that file will say on the first line channel pjsip 1000. So that is the extension number and the protocol. So all of the extensions we've created have been using the pjsip protocol, and that is the phone number that you're going to want to ring. Okay, and then we just have a stroke n at the end. That's going to put a new line in the call file, which is how it needs to be separated, the different fields in it. So we just put a new line at the end of each line of data there. So first of all, that is going to be the channel that we want to call. The next line in the call file in this example is going to directly say the name of an application. So whereas we were writing in the call file before, we had a context and we said an extension number and we answered the call, and then on the next line down we called a command like say digits. Here we're calling the say digits command straight away as the application, and we're going to pass the parameter to say digits in this variable here called data, and we're going to record whatever data was passed on the command URL, sorry, when this script was called. So when call type is say digits, then we're going to call say digits and we're going to pass it whatever data was sent in the parameter data. Okay, so having saved that PHP file, what I'm now going to do is copy it onto the Raspberry Pi into a directory that is accessible through the web. So I'm going to place it in this directory here. So in the var www HTML directory, that's going to be the root directory of the web server that's running on the Raspberry Pi. I've placed it in a subfolder which I've just called phone game, and I've called this file initiatecall.php, which I'm just going to place into the root here. Okay, and now if I load up my web browser, like this. And I'm going to go to my raspberrypbx.local, so that's my local web server. That's the same thing as typing the IP address. So if you'd rather do it by IP address, mine is 192.168.1.33. I'm then going to go into that phone game subdirectory, and I'm going to call the initiate call.php script and pass those two parameters. So I'm going to say call type is say digits, and data this time I'm just going to say is 1, 2, 3, 4. And when I go to that in my browser, this is the call file that gets generated. And when I answer that call, 2, 3, 4, you can hear the digits being spoken out. Now, okay, so that's what is going to happen. So having defined that into the call data variable, there's actually a little bit more at the bottom here, because we write that information there to the call file, which we generated at the beginning, and we just output that information onto the screen. That's going to help with debugging as well. That's not important. We'll close the handle to the file. And then this last step is important here, because what we're now going to do is, having been working with a temporary file through this whole script, we're now going to copy it into this directory here. And this is what I was talking about, this spool file that Asterisks works through. So any files placed in this directory here are going to be call files which Asterisks will attempt to place. And it just does it automatically. It flushes through that directory every time a file is placed there. And that's what plays the call. So let me show you another example. So calling this same script, but now this time we'll set the call type to say message instead. And when we do this, we're going to pass a different parameter. We're still passing data, but it's going to use that data to set the value of a local variable called message. And then it's going to place the call in the context of say message. So to explain how that's going to work, I need to show you the call plan that corresponds to this context. So here is the call file that shows that say message context. So in this example, when the call file is placed, the call is immediately placed into this say message context. And the first line here says, okay, so the first priority at the start of this extension is going to answer the call. And then we're going to use the pktts AGI script, which is the text-to-speech script we showed last video. And we're going to play the contents of the variable message. Now, nowhere in this context did we actually define what that message was. That gets passed in instead here. So this set message equals that happens in the call file itself sets the value of a channel variable that we can then access in the message itself. So to show that in action, if I go back to my web browser again, and we'll go to so again we'll go to my local web address, phone game initiate call, and this time instead of say digits we'll pass the call type of say message, and the data will type what I wrote before. This is a new message sent from the web, or something like that. So this is the call file that it is created based on that. If I answer the phone.
This is a new message sent from the web.
There we go. So that is a different example. Rather than calling an application directly, it's placed the call into a context here, and the context has been passed a variable, which is this set message here, and then it just read out that variable. And then the final example call type that's included in the PHP file here. So the default, if no other type of call is specified. So again, we'll call the extension 1000. We'll place it into a context called incoming play message. Now this time we don't pass a variable across. We're not passing any parameters. We're simply placing the call into a context called incoming play message. And incoming play message is this context here. So it's going to answer the call, wait for 2 seconds, and then it's going to play back a recording, which is Arduino calling, and that was the message you heard me play earlier. So I can just demonstrate that one more time. So we'll go here, we'll call to initiate call, but this time we won't send any additional parameters. We'll just call the script itself, so that default case gets executed.
Hello, this is your Arduino calling.
Okay, and that was the script that gets called from the Arduino. Now obviously that message said this is your Arduino calling, which in this case it wasn't actually. This came from the web. So now let's have a look at how you would make an Arduino place this call instead. And to do that, what we need to do is to write some Arduino code that's going to make an HTTP request to this address here. And here is that Arduino code. So starting at the beginning, the first thing I'm doing is including the library that's going to provide the functions for accessing the Wi-Fi. Now I'm using an ESP8266 board, so I'm including this library. If you're doing this on a regular Arduino, you'd simply include this Wi-Fi library instead. They provide equivalent functionality and they have the same named functions, so other than that the script remains identical. And then we define some constants. So this is the SSID name of the Wi-Fi network you want to connect to, and this is the password which you use to connect to that network. To trigger this call, I'm using a button which is connected to GPIO pin 12, but obviously you can make that any one you want. Now I put in the comments here, one thing I thought might be quite fun is to make this, rather than a simple switch push button, you could add a PIR sensor to that button which would detect when someone walked past and would automatically make the phone ring. But it can be any kind of sensor you want. When this changes from high to low, that's what's going to trigger the call to be made anyway. We also need to know the address of the Raspberry Pi which is running the web server. So this is the same address that we've used throughout all these projects that's running Asterisk and has the web server on it. And the address of the PHP script on that web server. So this is going to be the URL that we're going to access. Now, so we put it in a subdirectory called phone game, and we're calling initiate call.php, which is exactly the same script as we were calling from our web browser a moment ago. Notice that I haven't provided any additional parameters here. I've not specified the call type or the data, so it's going to fall through to that default case, which is going to read out the message, hello, this is your Arduino calling. And we're going to make an HTTP request on port 80. So these are all going to remain constant for the whole of the script. You just change these to match the relevant details for your network. We'll define a few globals, so we'll instantiate the Wi-Fi client object, and we'll call it Wi-Fi client. And we'll also just keep track of what the previous value of the switch was. So we'll read it each frame just so we can check when it's changed value from low to high and trigger that call. So that's going to be like a primitive sort of debouncing method on the button itself. Then we'll go through some setup procedures. So we'll initialize the switch pin as an input pull-up. So that will pull up its default state to high and just make sure that that button doesn't float around and accidentally trigger a call when we don't want it to. So I'm going to pull it to high. We'll start a serial connection which we'll just use for debugging information. It's not actually required. This bit here, I think this is only required if you're using an 8266 chip, because the chip on a WeMOS or something like that is capable of acting both as a Wi-Fi client but also as a sort of an access point. But we really only want to use it in one mode at once. We don't want to sort of generate the potential for network interference. So this just forces it to use one mode. I think if you're using an Arduino in an Ethernet shield or an Arduino in a Wi-Fi shield, I don't think this line is required. This is a kind of a slight peculiarity of the 8266 Wi-Fi implementation. And we'll open a connection to the Wi-Fi network using the SSID and the password that we specified in the constant section at the top. and we'll just wait for it to become connected, and we'll just print out a little line of dots while we're waiting for that to become connected. When that's finished, so when we have connected successfully, we'll just dump out some information to the serial link. So that's all the setup complete. We now go through the main program loop, which is here. So on every frame that we step through the loop, we're going to check the value of the switch pin, so the pin that we've got our switch or sensor or whatever it is attached to that's going to trigger the phone call. And remember, we define this as an input pull-up, so it's high by default. So what we'll do is we'll check if it's been pulled low. That means the switch or the sensor has been activated. If it's pulled low but it previously was high, that means that it's only been pressed this frame. So if we only checked whether the value is low, we could risk kind of running this every frame while the button was being held down, and we'd kind of make, you know, tons of phone calls one after another. By checking that it's low now but it was high before, that means we know it's only just been pressed this frame. So we'll put out some debugging information saying what we're going to do. We will just check that we're still able to connect to the host. So if we're not able to connect to the host at this point, we'll put out some debug information and return out of the loop, but otherwise we'll carry on. And then this is a slight sort of peculiarity in the syntax, I suppose, because you'll see the print command here, but we're not printing to the serial connection, which is what you might be more familiar with. So we're not sending any debug information here. We're printing to the Wi-Fi client, and that's the way that you actually retrieve web pages using the Wi-Fi client, or to make get or post requests over HTTP. So you print the command you want to the Wi-Fi client. So in this case, what we're going to do is we're going to print get and then the name of the page that we want to get. So this URL is the PHP script initiate call that we defined at the top. We're going to get that using the HTTP 1.1 protocol from the host, and the host again was specified in the constant section. That's the IP address of the Raspberry Pi. So we're going to get that URL from the host, and then we're going to close that connection. So this whole section here, this is the standard way by which in a web browser, when you click on a link to go to a web page, this effectively is the command that a web browser issues. What we're going to do is we're going to issue that command manually to our Wi-Fi client on our Arduino or ESP8266 instead. And once we've done that, we'll give it a little bit of time to retrieve that message. So specifically, this is actually going to wait for 2 seconds, because this is whatever the current time is at the moment, plus 2000 milliseconds. And we'll wait to see whether we get a response in that time. If we don't, we'll say that it's timed out. If we do get a response, however, what we're going to do is we'll read the response and we'll print it to the serial connection. So what we've made effectively is a very simple web browser running on an Arduino here. We're going to print the response, we're going to show it to the screen, and then finally what we'll do is just update the switch value to say that, hang on, we've run the script once this frame already, just to prevent that being re-triggered the next frame. This else here, this else belongs to the if we had right at the top. So this if value low here, if the value is not low, then we'll just say that the previous switch value is high. So all the magic really happens in this line, or this set of lines here. And what that's doing is that is getting the URL of the PHP script, which in turn is creating that call file, placing it in the queue. Asterisk is making the call. So now I'm just going to copy that sketch up to my board, and I'm going to run it with the serial monitor attached so that you can see the output from those debug messages as the sketch runs. So you'll be able to see when the Wi-Fi connection has been made and when the HTTP request is made to the web page. So just uploading it now, and hopefully in a moment in the serial monitor. Okay, so we've got the serial connection started. It's now connecting to the network. and it's connected, so it's pretty quick actually. It's only a couple of seconds it takes to connect to the Wi-Fi. Been assigned an IP address via DHCP, and now it is ready, and it's just waiting, looping round, waiting to listen to the state of that button to change. So if I now press that button, what you'll see is a load of information come up on the screen, which I'll talk through in a second, but first of all I've just got to answer this phone call.
Hello, this is your Arduino Code.
So obviously, just to confirm what we did there, so we made an HTTP GET request to that PHP script, so that's exactly the same script we were calling from the website. We didn't pass any additional parameters on the end of the URL, so we didn't specify a call type or send any data. So that just passed through to the default case, which was reading out that message that said, "Hello, this is your Arduino calling." And when we made that request, well, we know it was a successful request because we actually had the phone call made, but we do get the response from the web server as well here. So we have a 200 status message, which is okay, and we get some information thrown back by the server, and this is the contents of the page itself, basically. So if we were viewing this in a browser, this would be formatted nicely, and we'd see the contents here. Because this isn't a full browser, we've got the HTML tags and things, so just ignore paragraph mark. But we can see that it successfully wrote 64 bytes of the call file. It specified the channel of 1000, which is the extension number of my rotary handset here. It placed that call into the context called incoming play message, and it began with the start extension in that context, which is what caused the audio to play. And that's it. That's the end of this video. So that's shown you how you can create a call file dynamically. I mean, I'm using PHP, but you could use any other scripting language if you're more comfortable with that. But to programmatically create a little text file that just has contents like this, to place it in that outgoing spool directory that Asterisk processes. And I've shown you a couple of different examples, one of which, like this one, places it in a context, and when you're in a context you can then follow any of the rules in the dial plan that we looked at in the last video. Alternatively, you can call an application directly, like say digits, and pass it data, and you can also pass in variables in the call file itself. So that's a really cool way that you can create incoming calls and start a phone interaction that way, rather than make the player have to make an outgoing call. So I hope you found that useful and helpful, and if you've got any questions, please put them in the comments below, and thanks very much for watching.